So now we're moving on to another mind-boggling bit, which is artificial intelligence. And here to explain how it works is Thomas Nilsson from Ledeye, or as we refer to him, AI Thomas.
Thank you. Thank you. So now we talk about friendly and kind artificial intelligence, because it can be friendly and kind. We will actually show how to use it for, let's say, keeping the garment in the circular flow one more time. So imagine it's actually fails for a second hand. It's in a condition which is really not attractive. Now we will show how to actually bring it back, keep it in the cycle. So friendly and kind artificial intelligence for remake. So, and this is what I do for living, not only in textile, but making AI, which is friendly and kind. I also help organizations with strategies, how to, let's say, adapt to data and AI and any risks or opportunities in that, which is fit for the future. Yeah. So this is the studio. It's a style shoot, which we actually rebuilt a bit. So there are 4 cameras there now, standard cameras. It's 4K color cameras from Axis in this case. We use LED lighting to keep it energy efficient for the light source. So basically we adapt it to the Eton system. And when the garment come into the photo studio, we take pictures with 2 cameras on the back, 2 cameras on the front. Then we look for anything that might be the reason why it was not attractive enough. As Mikael showed us, there is a 3D or more voluminous kind of hanger to kind of so that we expose what we have in the shoulder area or collar or whatever. Yeah. So these are the 4 angles we look at. So one idea is, of course, to recalculate everything to a front side and a back side, because when you work on it later on to repair, you might want to have it on a flat geometry on a table, for example, as Mikael showed us. So therefore we have to kind of map it from this more, let's say, human or 3D shape into what it would look like on the table. So we take photos here, we analyze, or rather we let the technology help us, the artificial intelligence kindly help us. And then we recalculate, okay, where is this position on the table? How can I make it? How can I fix it so it's so attractive it will actually gain a new customer in the second hand? So typically one of the AI technologies we use is object detection. So we look on the picture, we learn the computer to identify, let's say, buttons, collar, stains, fat stains, or even armpit stains from the deodorant, rips, holes, various kinds of defects. And then it's going to tell us where they are and how large they are. So then we can apply some logic or some smartness from our human intelligence to tell it, okay, this is, we should treat it by embroidery. We put an embroidery on top. Or we should fold in the collar and sew it so that we have, let's say, kind of collar repair. So the computer took numbers, so just like Anneli, it's a lot of numbers, but we interpret them in a way that we get a language. So Matthias will show later that we get some kind of spoken language kind of output, but also we get some numbers output, so the machine can do it. So exactly. So first is to look for stain, holes, button, collar, a lot of stuff in 4 angles. Then check if, okay, let's say you find a hole here. It might be visible from multiple angles. So I need to understand if it's the same thing seen from many cameras or if it's actually two different things. So we can take away some of those defects because they were seen twice. And then we put them in a list. We look on, we transform to coordinates in millimeters, like the center front, center back. We also use high point shoulder, this point here. So we have the different coordinate systems as a mender or textile professional would use to find where is the object. So we generate kind of a short list out of all those numbers. So this is an example. So one way of mapping coordinates is that you have a couple of reference points, as you see those with the red boxes here. So they indicate a way for us to understand how is the garment hanging. Later on, we tried also other techniques, but eventually, or in the end, we found that this calibration chart, where we have it with a lot of, it looks a little bit fancy with the crosses and the boxes, etc. This is our calibration chart. So we have multiple of, let's say, positions which we can transfer between the two cameras and between the camera angle and the flat table where we make the remake. So another example could look like this. So you can see there is the picture original, and it finds a lot of buttons. We can look, for example, missing button, or we can look for stains. So there can be a lot of these. So this is, of course, looking a little bit messy, this picture. We make it into a spoken language for the mender to exactly tell what to do, what is the recommendation to make it more attractive. So everything is logged in the database. We can apply different methods, different also prints or patterns of an embroidery. So this is, of course, depending on the garments, if it's a white shirt or if it's a yellow blouse or what kind of garment we have. So far, we dealt mainly with upper body, so like tops, shirts, etc. So this is one of the strategies, and it's not intended to read it all, but this is a way to describe how we deal with the information. So, okay, we now know a couple of problems. What can we do about them? So there could be prints on top. There could be embroideries. There could be that we kind of fold it away. So then it follows kind of a tree path downhill a little bit going to see what is a recommended action. And this we configure easily. So we have an Excel file that anybody can change. So if it's, let's say, smaller arrows and some specific number, we can have one strategy and another strategy for larger problems. And maybe some embroidery or some print. So this is kind of the intelligence in it. So one part to see in the picture, understand if it's the same thing you see twice, then to apply a recipe. It's like baking pancakes. I mean, platta, pannkakor, crepes, it's kind of more or less the same, but a little bit different. So you can apply it differently to make it as attractive as possible. And this is just a picture to show how to configure. So for this system, there are a couple of files you can easily configure from outside then to tell how you want it to behave. So in a full production, you would, of course, want to adjust this for let's say, every second or third day until it's perfectly fit. This is the Kaizen, or the continuous improvement process we've been doing since Japanese started with it in the 50s. So you improve it, and after a while, it's going to perform. So this is very often the case of AI. If it makes some mistakes in its judgments, then you include them in a data set and you retrain. And after a while, it's going to be pretty good, just like Spotify. In the first use, well, it doesn't really know you, but after a while, it's going to know you well and suggest good music. In this case, good repair actions. It's a lot of numbers. This is a way to try to show it as pictures. Let's say we have multiple holes. Something was happening. They were working in the garage with it or something. And then there are multiple repairs. So then we have an idea how to consolidate and to choose which repair action. So if we have, let's say, I don't know, a butterfly embroidery at the head on one picture or something else. Okay, which one will be the one we use if we can consolidate from many small repairs to a fewer bigger? So we have a way to kind of consolidate until it's, okay, that's going to be one big print and there's going to be a small embroidery. This is, of course, an extreme case. If you have two things, you are likely not to process it in the remake. But if there is one thing, it might be worth. So there is always a judgment kind of, or you have to call what is the customer looking for in the second hand? How willing are they for let's say, more very expressive? The more expressive you can live with, the more, of course, things you can do with the garment, making it an interesting piece of your appearance. So it could look like this, for example. Now it's just an broader example, but so shirt might be something. Maybe we want to cover it up with a embroidery. So and then, of course, some text, as we said, for a mender. So the idea is that you could then pack this garment, you can ship it to somebody who can do the repair manually, or we can have a machine that does it. So this is actually the main wish. So how many machine builders do we have here today who actually make textile machines? Do you have any rising hands? Not very many, or are you? Just try. Okay, but if there are, we are very much looking forward to collaborations to take it, let's say, the next step. So after we have seen what to do with the garment, we have kind of applied a recipe how to make it really attractive again, so we can sell it on second hand. But then a way to automatically repair if possible, either a flat geometry, just like Mikael discussed, or in a 3D geometry if possible to apply with some grip tools and some robot. But this is really a next step of it. And when we have it, we actually have a solution for keeping the circular loop one more turn. Okay, thank you. So this was kind of the speech. My coordinates, we are in Västerås, but I'm often in Borås area. And do different AI projects such as this.